Look, on this video we do example 6.4 in the book. It's a basic transportation problem. We're not really choosing a location. We're choosing from existing locations how much to use each of these existing locations. And it's shipping from a capacity choice to a demand center. So it's a from to type problem. So here's the data that we've got. We've got 3 places where we have capacity. So these are 3 places that we make something. And we've broken down our demand world into 4 demand centers. So we have 4 demand centers, and this is the demand at each of these locations. And if you notice, the capacity, if I sum this, the sum of that is 15,000, and the demand requirement is 13,000. So we're going to be able to meet demand. The question is, we want to be able to do this in the cheapest way possible. And this is the per unit cost. So we want to use the cheapest lanes, but we can't exceed our capacity at each of the locations. So here's how I solve this. The very first thing I do is I'm going to grab all of this, and I'm going to copy, and I'm going to go down one like this. And then these become the sum of these. And these are going to be my decision variables. This is what I'm going to let the model have control over, is these 12 from twos. And I'm going to go ahead and just start out, make them 0. You don't have to do this, but it'll make it easier, I think, to see for the first time. So these are my cost drivers. These are my capacity limitations. These are my demand requirements. These 12 variables will represent how much I ship from Cleveland to Boston, Cleveland to Chicago, Cleveland to St. Louis, all the way down to York to Lexington. And this will be the how much, this is my used capacity. And this is going to be the demand met, the actual amount that's shipped. So now that I have this, I can first of all calculate my overall transportation cost. And it is a sum product. This is a great formula because it can actually multiply arrays together, not just vectors. So it will do the paired multiplication and add all those up. And that's what I'm going to try to make as small as possible. I'm going to try to minimize my cost. Try to minimize this. All right, so I think that's everything I need to set up. Now I go under Data Solver. And what I try to do is I'm going to take this cell and I want to minimize it by changing these 12 cells. That's the only cells. Notice I don't pick anything else. Be real careful of grabbing something that you don't want. Only grab those 12. Those are my decision variables, or my unknowns. And then I need to add some constraints. Now I'm going to add these in sets. So really right now I'm going to write 3 constraints, but I'm actually going to write one set of 3 constraints, where I'm going to say these 3 as a set need to be less than or equal to these. So that's actually saying this needs to be less than or equal to this needs to be less than or equal to this, and this needs to be less than or equal to this. Now I could have written 3, but this is a better way to write it. So that's one set of constraints. The other one is that demand have to be greater than or equal to my demand. Now you might say, well, why did you make it greater than? How come you didn't make it strictly equal? Well, I could, but the greater than equal to is better, because if I ever have to ship in batches that are larger than demand, so let's say I have to ship in pallet sizes or rail car quantities, and I can't ship exactly demand, this will allow me to meet demand and as with as little over that is necessary. And remember, the model's trying to minimize cost, so it's not going to ship more than it needs to. But if it has to because of minimum shipping quantities, this is a safer way to do it. And I think that's it. So look, this is what we've done. We've got a cell that we're trying to minimize by changing these cells. I've added 2 sets of constraints. Keep this checked. That forces everything not to be negative. We don't want any negative shipping quantities. And then the last thing is, don't forget to make that simplex. Hit solve. And that becomes the best answer. So let's look at it. We're not going to look at sensitivity reports with these videos. We'll probably talk about that in class. But if I look at this, I can see that Boston is served by 2 locations, Chicago is served by 2 locations, St. Louis is served by 1 location, and Lexington is served. I'll probably then, the locations that have a single source of supply are St. Louis and Lexington. Boston has 2, Chicago has 2. From a quality standpoint, I expect to probably have quality problems in this world because I have multiple sources of supply, so I've got to have a quality system that looks at 2 different suppliers as opposed to 1, and build relationships with 2 suppliers instead of 1. It gives me flexibility, but there's probably quality issues. It's always a trade-off. If I look at capacity used, I can see that I maxed out Cleveland and I maxed out York. I did not max out Bedford. Bedford is not a tight constraint. I only used 4,500 out of 6,000. So I don't need to add capacity at Bedford. I probably ought to take the capacity away from Bedford and use that either in Cleveland or York. And if I did that, I could probably reduce my shipping costs a little bit more. That's a good start. Thanks.